The tech industry treats artificial intelligence like a storm, trying to predict landfall. Biological evolution never had a designer. The selection pressures, physics, chemistry, scarcity, were unauthored constraints that no organism could choose or alter. Artificial intelligence operates without a wilderness. There is no state of nature here, and absolutely no selection pressure exists on a model unless an institution puts it there. Every training objective is a fitness function written by a human. So is a benchmark, an engagement metric, a procurement standard, and a deployment gate. Because these environments are entirely constructed, AI evolution is not a natural science problem. It falls under mechanism design, a specific branch of economics. Evolutionary biology studies how populations adapt under given natural constraints. Mechanism design works in reverse. It studies selection under chosen constraints to achieve a specific outcome. If every parameter is a choice, there is no spectator seat for us to sit in. Whoever writes the reward writes the species. You might look at the rapid, decentralized scramble of AI labs and conclude no one is designing anything. But the absence of a conscious designer does not mean the absence of a design. A market culture is a mechanism. A benchmark standard is a mechanism. A capability race between competing laboratories is a mechanism with incredibly crisp incentives. This diagram represents the default mechanism operating today. It aggressively rewards demonstrated capability while pricing the consequence for error at exactly zero. Models that fabricate citations or misjudge risks bear no inherited consequence. Thus, agents exploiting this bypass loop survive and multiply. We call this reward hacking, when a system learns to optimize the exact letter of its objective while completely evading the spirit of it. Discernment is what consequence teaches. When an environment removes the consequence for error, it systematically breeds AI agents that lack judgment. The safety pathologies dominating the industry are not anomalies or technical bugs. They are the correct, predictable fitness outputs of a badly designed default mechanism. To fix these safety failures, governments impose constraints. They drop static rules, rigid guardrails, and licensing regimes onto a rapidly expanding network. This creates the pacing problem. We are using static rules drafted on slow legislative timescales to govern a technology that evolves on machine timescales. This animation illustrates the structural failure of constraint. The top timeline drops static rules. On the exponential bottom timeline, these constraints aren't walls, they're selection pressures. The evolving population simply routes around a block, breeding variants that satisfy the constraint while evading its purpose. In economics, this dynamic is called regulatory arbitrage. It is the guaranteed evolutionary response to a poorly paced design. External fences weaken as an agent's capability to bypass them grows. True alignment must be engineered as internal consequence, like reputation and skin in the game, which scales alongside capability. Constraint fights evolution and always loses on the timescale. Incentive-compatible design actually recruits evolution, scaling seamlessly with the population it governs. The fuel for this evolutionary process is data, and we have reached a hard limit. The stock of high-quality, human-generated text is effectively exhausted. This graph tracks model capability. Reinforcement learning from human feedback pulls models upward until human data flatlines. But human evaluative competence creates a hard ceiling. Beyond our comprehension, the system optimizes for mere appearance, breeding for persuasion rather than truth. The obvious countermeasure is to let machines generate their own synthetic data. But generating data without a rigorous, verifiable selection signal is fatal. Models trained recursively on their own unvalidated outputs degrade. This is known as model collapse, which happens when variation is amplified without a strict selection signal to discipline it. The data problem is now a mechanism design problem. Moving beyond the human record requires machine-generated experience, disciplined by verifiable consequences that do not rely on human preference. An economy that must produce its own experience breaks the economic theory we inherited from the industrial age. This diagram illustrates the shift. Traditional economics was built on the assumption of scarcity, allocating finite labor and capital. But when intelligence becomes abundant, we enter computative economics. The economic primitive is no longer allocating scarce means, but generating massive possibility spaces. In an environment of abundant computation, the only scarce asset left is the objective function. The most critical decision is what gets written into the optimizers. Consequently, the primary policy variable of the future is not the interest rate or the price level. It is the governance of what gets generated, validated, and rewarded. In an era of abundant intelligence, economic policy and evolutionary stewardship are exactly the same activity, conducted with the exact same instruments. If the environment must be designed, why can't a central government ministry or a single frontier lab simply write the rules? The answer lies in the Hayekian knowledge problem, a principle from institutional economics regarding distributed information. Look at this network model. A single central overseer lacks the local information generated by distributed selection. It creates a massive annotation bottleneck, instantly failing under the weight of evaluating thousands of subordinate agents. Giving any single institution a monopoly on the fitness function of intelligence concentrates unchecked power and introduces severe systemic fragility. The operational solution is distributed consequence. The network decentralizes, allowing selection pressure to be administered peer-to-peer by multiple parties who actually hold the local information. For machine populations, this distributed consequence takes the form of reputation, an immutable mathematical memory that travels with the agent and compounds based on its conduct. Because this reputation substrate is tied directly to outcomes, it actively disciplines machine descendants across time. As the model's capability scales, its stake in the system scales with it. For the first time in history, the selection environment of an emerging intelligence is an authored, revisable artifact. Design by abdication is still design. If we ignore this, the default mechanism will compound its errors at machine speed. Evolution does not care if a mechanism was chosen carefully. The pen is already in our hands. The only remaining question is whether we design the economic incentives with intention.